In the next video we will see how and what to do to an old classic car to make it outstand successfully in the 2021 streets at night. Will its light perform as nowadays OEM headlights? And the most important, will this mood be really street legal in EU? Let's find out together. Here is how a 90 GM model looks like after 10 years since was last serviced with an aftermarket headlamp set. For this we will see next in our video what we designed and developed as a headlight kit to solve the major issues this car originally had. You are now about to see what was the exact initial problem, what the kit does to solve it, and a quick how to install tutorial with our LEDs. Note this kit is fully compatible with any other LEDs except the extra features, with both versions OEM or aftermarket sonar headlights. Which are the biggest benefits of having this installed? Corrected headlight position, plus reduced risk to break the clamping tabs. Quick release system of headlights from the vehicle, 5 minutes of pair removal, extra adjustment sliders, and, as optional extra features, aluminum custom heatsink covers, and LEDs pairs with high performance or default power supplies. We strongly recommend to wrap your new headlights from the day zero before even installing them on the car. This not only will prevent acrylic glass deterioration from road and car wash aggressive environment, but also with help to avoid any scratching on units during installation process. The wrapping film is not subject of this video, but per your choice higher quality films will last longer, while the low quality ones will be needed to be replaced more often. The problem which affected most of the cars launched in early 90s, from very common BMWs like E34, up to exotic cars like Lamborghini Diablo, Bugatti, EB110 or Ferrari 550, was the lethal combination of lens reflector plus halogen bulb, which was the factory prerequisite for the next best thing in the automotive headlights, headlight bulbs. But with halogen lens projectors, the resulting light was barely drivable, and probably still is for the very few ones who did not upgraded their original bulbs yet. The modern traffic conditions made this situation even worse. Their much brighter light is hitting the struggling eyes of the drivers who ride with this halogen system, while they are having wide open iris to focus on the much lower driving light. Besides the HID revolution, there were few other reasons why car makers did the lens step. Among them, the elimination of unwanted glares which classic mirrors had, and the will of having much slimmer flat-shaped headlights. Since OEM version is having the beam disperser embedded in the protective glass interfering with any other light source than the classic incandescent bulb, mirror peel-off issue and reflector melting flaws and very limited back clearance, we decided to work improving the aftermarket version. Now we know OEM back in the 90s mostly were a bad option, but why is the aftermarket Asia manufactured items the same as bad 20 years later? Because they failed to comply with the manufacturing and testing process. Since the cut-off shape of the low beam was supposed to be obtained somehow in a very limited space inside the projector, the easiest way, yet the most ineffective, was to use a black mask. This mask was absorbing everything which was lightening 50% below the bulb 15 degrees slice for the cut-off. This means 46% of the luminosity provided by the bulb is lost, converted into heat mostly. You may wonder why black, because the regulation also imposed minimal glare above the cut-off edge, 6 lux in .B50 BL, which in reflective finish couldn't be easily achieved. Note that if we coat only the last 5 mm of the edge, glare would be reduced the same, but since cost production for wide series was imposed for this product, then the manufacturer profit margin focus made it low performer item. Some good quality brands like Vauhxall, starting to mid-2000s, reduced the glare and uniformized the beam reflections by tuning the cutoff edge a bit lower and in addition adding micro facets on the glass lenses. These items hardly fit on the vehicle chassis, and the beams are misaligned with no direct option to be adjusted it by end customers. Almost all, despite their claim, have no TÜV certification. First thing to check is the overall shape and installed position onto the vehicle. The clearances with surrounding body panels needs to be assured, and the edges and fastening points shall be on the right spot. Therefore, here is where our kit comes in the picture. Let's move on to the next step. Choosing your LEDs and steps to follow for installing them into the headlights housing. After trying a lot of LEDs designs, different type, size or brand of the chip, we developed our own. The link where you can buy this LEDs kit solely it is in this YouTube video description below. Main failure reasons were Motorway authority declined the mood. Traffic participants got disturbed by side reflected rays. Driving experience, even if was slightly improved, was really not much better than the halogens over classic non-lens mirror projector. The new LED's light got faded with time, or got blinking dimming, while engine running hot. All of them needed replacement in about 4 to 6 months. If you choose to use your own LEDs, you must know there are 3 main factors which dictate the quality of the headlight performance and reliability. 1. The stability of the constant current power supply of your LEDs, including under the EMI stress conditions. The most common parasite of these PS units in classic cars are the windshield motors. 2. Temperature. Both LEDs chip and PS units needs to be under threshold limit when engine running hot. This scenario occurs very often, especially in countries with hot climate. If any of the two gets hotter, lighting system will prematurely fail. Be aware the headlight must have some metallic or metallic compound surfaces in vicinity of these units able to quickly dissipate heat. Full plastic housings are not suitable for this setup into the long life expectancy. 3. Size matters. With correct size of the LED's lamps, the heatsink side must allow the installation of the back covers. Do not let your headlights open. Otherwise dust will get inside the optical system in a matter of months and will deposit on mirrors and lenses, compromising the entire unit. LED's length must assure enough space to allow free movement of the leveling system. The LED's chip must sit correctly in the focal lens position. As final note, even with our LEDs, because aftermarket headlights are having a very loose tolerance from one item to the other, under same product code and same manufacturer, you must always need to do 2 steps verification of your LED converted headlights. First, off the car, then final check onto the vehicle. Even 2 degrees misrotated LED lamp will generate dramatically different beam shape and light intensity profile. Let's move on to the next step. Installation of LEDs inside the headlights and clean up the headlights harness. Step 1. Removing the CCFL imitation light. Remove the 3 bottom rubber covers. Step 2. Using an wire cutter plier, trim the 3 cable pairs from the lowest point you can get inside the headlight housing wall. Step 3. Take a glue gun stick and consecutively melt and cram it into the rubber covers. Step 4. Install back all the 3 rubber caps into their places. Step 5. Install first the low beam LED. Insert the H1 ring into the headlight socket and clip it in place with the lock wire. Step 6. Check the lock wire to not interfere with the LED heatsink. In case it does, slightly bend it against the opposite touching point using a plier. Step 7. Insert the power supply unit first, on the side of the projector bowl. Be careful to let it in a position which will not obstruct the leveling rod path. Step 8. Carefully insert and push the LED into the ring. Step 9. Connect your headlight to an 12-volt power supply and power up both low beam halogen and high beam LED. Step 10. Check the radial position of your LED. The LED needs to be sitting in the focal lens point. Slowly rotate left and right until one of the two may happen. 1. The highest light intensity, or 2. The socket wall is touched. Your purpose is to reach scenario 1. Step 11. Using the method presented later on in this video with the software tool, same used for LED checking on the vehicle, determine the elevation position of your halogen spot in relation with the LED hot spot. By the same method, you will observe and be able to decide what is the error of high beam hotspot position, X or Y axis, linear offset or radial angle. Step 12. Open up the high beam cover cap and disassemble the H1 bulb and steel plate holder from the high beam projector. Carefully pull it out using a magnetic pickup tool, avoiding dropping the screws inside the headlight. Step 13. Unscrew the corresponding bowl screw holder for the correction you need to take, according with results from Step 10. Step 14. With the help of an extended tip neodymium magnet for 90 degrees holding, insert one washer provided in the kit between the bowel and its holder. Be aware this step requires a high handiness technician to insert the washer. Step 15. Tight back the holding screw, then reinstall all the components back in place. Step 16. Do a final test for beams alignments with halogen bulb or the laser pointer provided in the kit. Step 17. Install the power supply and cable of the high beam LED. Check the locking wire in the same way you did at Step 5 and 6 for low beam. Step 18. Carefully place the LED cable in the correct position. If it will be 180 degree flipped, the electric leveling system will not work properly. Step 19. Cut each light function wire pair with the correct length and add the protection sleeve and the plastic clip for position light cable provided in the kit. Step 20. Add the high beam back cover, cable end seal, and cap rubber ring seal. Trough the wire, then carefully clamp one by one all the pins of the connector provided in the LED kit. Caution: incorrect wiring voids the warranty of the LEDs. Step 21. Add the low beam cable sleeve, cable end seal, cap rubber ring seal and cover the optional aluminum sector caps. Accepts inserting straight terminals. Trough the cable hole or bent 90 degrees terminals. Step 22. Repeat same process of the step 10 to check the correct rotation of the LED for high beam this time. Step 23. In this final step, if you ordered and installed our aluminum caps, carefully rotate them without disturbing the LED with the cable port towards the headlight bottom at 6 o'clock correct position. Now, your headlight is fully ready for installing it into the car. Before going to install the headlights on the vehicle, let's see a quick overview of our development process of this kit. Just like we presented in the Jaguar throttle body project, we firstly accomplished a requirements set. For this we performed adjustments in a loop for several 3D prints versions until all the dimensions and functionality were doing a perfect fit. Just after, we designed the molds and obtained first wax patterns. We got into metal cast from our supplier. Then we did the CNC machining for cable ports, PCB slots and sealing rings. As final step we completed the finished product by electroplating then powder coating. Our tab holder kit for low series is a fiber metal composite fully volumetric filled, which almost same weight as a 3D shallowed FDM ABS print. But the strength is way beyond the original headlight tabs. Because the lifetime warranty has been requested by some customers, we had to develop the 100 centigrades nominal running temperature for LEDs power supplies. This comes only as performance option, is not default included in any kit yet. After our test suite with these power supplies we can finally be proud to have them running the LEDs for a lifetime versus the standard 2-year limited warranty PS units. And since we wanted to last forever, we provided only no rust screws all the way into the entire kit. Let's go back to installation of the kit. Step 1. Remove the 3 screws on the bumper grill above coolant radiator. Step 2. Remove the 2 screws on the top sides of the bumper. Step 3. Pull the bumper towards front and sides to release the plastic clamps. Now the bumper is free to move downwards, easily push it, while guiding inside the black foam protection. Step 4. Unscrew the 2 screws of each headlight top tabs. Step 5. Unscrew the single bottom screw of each headlight placed underneath, behind the steel reinforcement bumper. Easily pull out the headlight and disconnect the 3 harness connectors of each unit. Now your headlight is free and can be removed. Transfer to your new headlights any accessories not available in your new headlights package like hazard bulb sockets, leveling actuators or position bulbs. Be aware with the aluminum low beam cover cap setup, the actuator and the cap are a very tight fit and this operation requires skilled technician. Quick tip: to correctly insert the actuator rod, first rotate for extending the rod, then insert into headlight slot, and rotate backward to retract the rod until the actuator body gets very close to its installed position. Once there, push and spin hard against metal cap and the headlight plastic. Once it got in, there will be re-established the approximate 2 to 3 mm clearance between the aluminum cap and the leveling actuator. Step 6. Install the lower arm holder from the kit on both headlights. Check for the markings left or right. After you tighten the 8 mm bolt, check the free rotational movement to be assured. Progressively readjust the nut until the piece stops gripping. Step 7. Install the fender side top tab holder and inner top side plastic inserts, but do not use yet top sliders. Step 8. Insert headlights in place. Connect back all the electrical harness connectors in the reverse order as they being disassembled. By helping with one hand from underneath, clip the bottom tab in the slot. Insert the top sliders and inner top screws of the headlights. Adjust from sliders for correct fender and hood clearance. Step 9. Light up your headlights and adjust the final inner top screw on each headlight. Caution: headlights will need to keep about 4 to 5 mm lip below the bumper top edge, all the rest needs to be above the bumper uncovered. If you drop your headlight below this threshold, light performance will be dramatically reduced, and the protective glass will risk to get shattered due to excessive focused heat. Step 10. Tuning with the electric leveling system and horizontal line, first stage. For this, you need one office projector connected to an PC, and one light meter unit, preferably on a tripod. Note we present this solution instead of the optics gonaphotometer method, because comparing with optical laboratory measurements, this is way more accessible to wide public. Basically almost any individual, garage or company can do it. With it, the obtained results are very good, and validated by motor authorities. Further on, you need to prepare ahead the vehicle as follows. Assure all the tires pressure according to your vehicle user manual. Set headlights leveling scroll button into position 0. Assure there is one person sitting on the driver's seat, and no other luggage load including empty trunk. The accepted gas tank level is about a half, and the car battery must be fully charged. Preferably perform further tests with a battery charger plugged in. Step 11. Take self-leveling laser tool available at any hardware store, and place it on the chassis between the headlights. Using an 13 ratchet spanner, adjust each headlight for the shortest distance to the even level. Once done, check the electric leveling system to fully operate on the entire range. Step 12. Tuning the short range and preparing for last check at 25-meter projection wall. At this step we check and adjust the cutoff height and angle to correct position. Bring your vehicle at exact 4 meter far from the projection wall. This dimension is part of ECE requirements for homologation. Measure the projected scaling factor unit and use zoom in out button from the tool until the unit gets to the correct size of centimeters. The headlights will be needed to be tuned individually, the left and the right, so go to fuse box compartment and remove the fuse for the headlight which you are not tuning at the time. Now we have all set. The cut-off horizontal line shall match the reference projected dot line. If not yet, adjust further with the ratchet used in previous step. Now, using a T30 screwdriver you can adjust the inner screws in order to tune the cut-off angle to the exact 15 degrees, if the case. Measuring method for the 25 meters projection test consists in placing the tripod in the position which the center of the lux meter head will perfectly align with the center cross of all the 8 control points. Quick tip, use a white cardboard mask for assisting you placing the tripod with higher accuracy. Once you enter your measurements one by one in our software, you will be prompted in real time for all the 8 fields with any non-conform values if found. For your high beam, be aware you only need to check the hot spots position, which is having different symbol marker than luminosity control points. For the short range test, only the 50R luminance value will be helpful in order to check for symmetry between left and right headlight. In the next video part 2, we will reveal you the final results for the 25 meters test. But by then, feel free to vote and get yourself this headlights holder kit. You already saw the kit has undeniable positive role and value in how your headlights sit and perform on the chassis. Link with the kit, it can be found in this YouTube video description below. The software tool will be offered for free to all of you who have an active order or just an poll vote for this kit. For any other car you may have, and you need such build, it will be our pleasure to make it for you.
Because building automotive parts, either as functional prototypes or small series, is the end-all and be-all of our service.
Subscribe to support our channel and see the further updates or any other projects like this.
Sector, a legacy from the future.